A relatively simple problem in physics I want to talk about are generally these easy work problems. And I'm going to kind of relate work and energy. I think of work as what you applied, well, work is what you accomplished maybe, and energy is what you applied to accomplish that work. So, for instance, I want to simply look at this scenario where I'm relocating, or this person is relocating a box from position A to position B. How long is it, how much is it relocated? By distance D. How much did he have to push? With a force F. So this is what we call horizontal motion. And so generally we can just kind of knock out a quick work problem. Work is the force that he applied times the distance over which he applied it. So here's a thought. Now what if this person is trying to move a brick wall? Okay, here we have this person applying a force F, but notice that there's no movement. So that makes the D term 0. And so that makes the work done also 0. Makes sense? So, like I said, this is kind of a very limited sort of work problem I want to focus on this semester. Now, work is in units of actually energy. In the metric system, the metric standard unit of energy is the joule. The joule actually can be broken down in kilograms meters squared per second squared. Just kind of making sure we're all on the same page. Up here, this is a little bit bigger. If I focus on my work is force applied times the distance over which that force was applied. Force is going to be units of newtons, and distance is going to be units of meters. So that's why down here the unit of a joule is also a newton meter. So let's work a few problems. I got my calculator here. Let's not make it harder than it is. Remember, on a unit exam, I'm going to go ahead and give you formula sheets. So, for instance, in this scenario up here, what if the force that guy is applying is 2.5 newtons? 2.5 newtons in the direction shown. And let's say that how long he applies the force is the distance is equal to 6.12 meters. We can knock out then the work. This is kind of how I work problems. I just kind of pull the information out, and then I'm going to refer to work as force times distance. So work is 2.5 newtons, put that in parentheses, times the distance of 6.12 meters. Not bad. So we talked kind of about rounding, and it looks like since I have 2 digits right here, that I'm going to actually round to just 2 digits. So if I put 2.5 times 6.12 in my calculator actually displays 15.3, calc 15.3. Remember I told you units for these problems are going to be joules. Same thing as a newton meter is the same thing as a joule. But notice that I need to round. I told you 2 digits, so actually the better answer would be 15.3 joules. Okay? It's alright. Well, let's take it up a notch, or take it down a notch. Notice that if you read this problem, you're going to see we're going to relocate the box the same amount of distance, so that's my D. But in this case, I want to not apply, what was it, 2.5 newtons, but I want to go 2.3 times 10 to the negative 6th newtons. So here's where you're going to get a little bit of work. You're going to, no pun intended, you're going to get a little bit of exposure to using scientific notation in your calculator. So I'm always about showing all work, so no pun intended again here. So work is force times distance. So here work is that the force is 2.3 times 10 to the negative 6 newtons. So we would expect the work to be significantly less, right? Because the force is significantly less. The distance is the same, 6.12 meters. So now I'm going to kind of talk you through my calculator. Is I go 2.3, I hit my EE key, and I'm going to do the negative 6, and then I'll simply say times 6.12. And again, well, To round, actually, I'm going to count. This is 2 digits right here, and this is 3 digits, so I'm going to go with 2 digits again. So my calculator says, or displays, something like 1.4076. Units would be, times 10 raised to the negative fifth. Units would be joules. The answer is going to be only 2 digits, and my 2 digits then, I'm going to actually keep the 1 and keep the 0.4. So my answer is 1.4 times 10 to the negative fifth joules. That is the answer. Okay, so I hope that works for you. I'm going to go ahead and turn this into a video question. So how much work was expended if you go ahead and push with a force of 2.5 newtons? That looks like the same force in the first problem on the slide. But instead of a distance of 6.12 meters, we're going to go for 12 meters. So what work was spent